In this lesson we're going to look at what we mean by a moment, or the moment of a force, and moments apply to objects which rotate around a pivot point. So in this setup here we've got a beam which rotates around a pivot. Okay, so that's the pivot, that's the point of rotation, and we've got a force F which in this particular case is acting at a perpendicular direction to the beam, and this direction of action of the force is called the line of action. So the moment produced by this force is equal to F multiplied by the perpendicular distance from the line of action of the force to the pivot point. By perpendicular, what we're doing is we're drawing a line which is at right angles to this line of action of the force, and we're measuring the distance between that line of action to the pivot. So we'll just call that distance r, and we'll say that the moment is equal to F times r. Now, I'm going to be talking a lot about moments in the following lessons, so saying perpendicular distance to the pivot is a bit of a mouthful, so we'll tend to miss out the word perpendicular and just refer to it as the distance to the pivot. And in pretty much all of our situations we look at, calculating or measuring this perpendicular distance is fairly straightforward, because our force is nearly always acting at right angles to the beam, but not always. So you might get a situation like this, just to try and emphasize the point, where instead of the force acting vertically downwards, perhaps it acts in this direction. So the direction of the line of action is no longer perpendicular to the beam, so we're going to have to recalculate the perpendicular distance to the pivot. So we'll remove this. Here's the line of action of the force, so this distance is now the perpendicular distance between the line of action to the force and the pivot point. Okay, so the size of the force is still the same, but because it's inclined in this direction, the perpendicular distance is now less than it was in the previous example, and so the moment produced by this force will be less. In most situations we're going to encounter a force which is perpendicular to the beam, so that makes life a lot less complicated. But there are one or two situations where you need to consider forces which are inclined in this way, and then you have to think carefully about what the perpendicular distance actually is. Okay, so let's just go back to our previous example, and as we've just stated, our moment is the force times the perpendicular distance to the pivot, and that's equal to F times r. So we'll give the moment the symbol capital M. Okay, so as we do very often in physics, where we have a relationship like this, we can form a calculation triangle to help us calculate our moments. All right, you've seen those before, where if you're not too hot at rearranging expressions or formulas, you can use this calculation triangle. So when we have the format something equals something times something, well, we put the something times something at the bottom, that's F times r, and there the moment at the top. So the moment is equal to F times r. Okay, so in this setup here, what is the moment produced by, say, a force of 30 newtons acting at a distance of, say, 2 meters from a pivot point? Okay, so you calculate the moment, substitute into the expression is equal to 30 times 2, which will be equal to 60, and the unit for moment is, well, the unit for force is the Newton, and the unit for distance is the meter, as you well know, so the unit for the moment is the Newton meter, 60 Newton meters. So just before we finish, I just wanted to point out that the expression moment, or the moment of a force, is also known as the turning force. So we can talk about a turning force. So you can ask, what is the turning force produced by a force of 30 newtons acting at a distance of 2 meters from the pivot? So another word for the moment is the turning force. Now there is just one final point that I need to make, and it's very important. I forgot to mention this earlier, and as you know, a moment of a force or a turning force causes an object to turn. So we need to specify whether the moment is a clockwise moment, let's say whether it causes the object to turn in a clockwise direction, or an anti-clockwise moment. So in this particular case, with the force acting downwards, we've got an anti-clockwise moment produced. So we should specify in this particular example that we have an anti-clockwise moment of 60 Newton meters. If the force were acting in the opposite direction, then it would produce a clockwise moment.